All right, function notation, mid-unit 4, practice test. Question 3. This graph represents Andre's distance from his bicycle as he walks in a park. Okay, so when you're looking at a graph, the number one thing you want to do every single time is take a good look at your axes, right? Over here, I got distance in feet. It goes up and down. That's my y value. In this case, in function notation, we could call this d of t. Distance is a function of time. And here is my input on my horizontal axis. I got my x values, and these are time in seconds. So we plug in one of these times in seconds, and it's going to give us back the distance in feet. So decide whether the following statements are true or false. The graph has multiple horizontal intercepts. So what is an intercept? An intercept is where the graph crosses either your horizontal axis. Remember, horizontal goes left and right, just like the horizon. If you look out at the sunrise or sunset, you'll see it'll be setting on the horizon, which goes left and right, just like this word horizontal for our horizontal axis. If they asked us about a vertical intercept, we would look at our vertical. Vertical means up and down, straight up and down. And this would be our vertical axis. And technically, we've got a point right here, 0, 0, or it looks like it's a vertical and horizontal intercept at the same time. Now, multiple horizontal intercepts. Here's one right here, somewhere about right there. This graph is crossing the horizontal axis. That'll be a horizontal intercept. And over here, this is where Andre got back to his bicycle, right? He left his bicycle over here. He was 0 feet away from the bike. And then when he got back over here after about 27 seconds, he was, again, 0 feet away from his bicycle. So here's our two horizontal intercepts right there. A is true. So now B, a horizontal intercept of the graph represents the time when Andre was with his bike. And so yes, the horizontal intercept is where y equals 0, or in this function notation, where d of t equals 0. And if we read the graph, it says that this graph represents the distance from his bicycle. And so here he was at these green dots at 0, 0. He was with the bicycle. And after 27 seconds, he was with the bicycle. So let's take a look. Though that's true. B is going to be true. I'm going to circle that one. Next, we got C. It says a minimum of the graph is 17.1. Okay, so there's two kinds of minimums. I've been watching a lot of Khan Academy videos, and they talk about absolute minimums or maximums and relative minimums or maximums. So you might be inclined to say, look, a minimum is right here, where he's 0 feet away from his bicycle. These horizontal intercepts are minimums. But you know what? This also right there at the bottom of this slope right here, he got real close to his bicycle. He got within 1 foot of his bicycle. So that is a relative minimum. So I would say, because it says A, if it said the minimum, I wouldn't choose that one. But it says a minimum. I'm going to go ahead and say that one's true right there. D, make sure I keep that C circled. D, the graph has two maximums. Now here's a little bit of gray area, okay? I picked this right out of the Kendall Hunt illustrative mathematics curriculum. And I personally wouldn't want to put this on a test because the graph has two maximums. If these 2 points were like exactly the same height, right here, maybe at about 21, 8.5. If this was exactly the same height as that, I would say that that's true. But when it says it has two maximums, if they said relative maximums, for sure that's true. But me personally, when I'm reading this question, I'm going to say that my maximum is right here. because this one's a little bit taller after about 21 seconds. So I'm not going to pick that one. But there is some gray area. This could be arguable. You could make the claim that there are two maximums. Next, about 21 seconds after he left his bike, he was the farthest away from it at about 8.3. And this is that maximum we were just talking about. So they're saying that's about 8.3 high. So we would write this, if we write it as a coordinate pair, the x value goes on the left and the y value goes on the right. Or no, I'm sorry, I'm reading option C, getting confused here. This point right here is after 21 seconds, this person, Andre, was 8.3 seconds, 8.3 feet away from their bicycle. And this is that maximum that I was referring to when we were reading D. And that it looks pretty true. That's close enough to 8.3 for me. I mean, when I look at the graph, I'm thinking it might be 8.1, but if we're talking about tenths, this decimal, this tenth of a foot, that's pretty hard to tell from a graph. I'm going to have to go and assume that that's true right there. And those are the ones that I would choose for this. Mostly on this question, you just want to know what are your vertical intercepts, are right here, right? Your vertical intercept is anywhere the graph crosses the vertical axis. Your horizontal intercept is anywhere where the graph crosses the horizontal axis. You want to know that you plug in T to get your feet.